multiply and then simplify the products. We can solve this problem by using the FOIL method: first, outer, inner, last, or we can use the box. I like the box because I can organize my work. So I have the square root of 11 plus 3 square root of 5 times the square root of 11 plus 5 square root of 5. So when we multiply the square root of 11 times the square root of 11, we're using the product rule for radicals. So that rule states that if we have the nth root of a times the nth root of b, as long as the indexes are the same, then we can multiply the radicand. So we get ab and then the index stays the same. So here we don't have an index, so that's an understood 2. So because they are the same, we can multiply 11 times 11, which is equal to 121, which simplifies to 11. So the square root of 121 is equal to 11. To multiply these out here, we have an understood 2 there. We can use this rule here to multiply the radicals, but we have to account for this 5 and an understood 1 that we have here in the front. The numbers on the outside get multiplied and they stay on the outside. So 1 times 5 is equal to 5. And then the square root of 11 times the square root of 5 is equal to the square root of 55. So this one we have an understood 1 there too. So 3 times 1 is 3, square root of 55. And then 3 times 5 is 15, and then square root of 25. But the square root of 25 is equal to 5. So now we have 15 times 5, which is equal to 75. So now we can add the 11 and the 75, and we get 86. And then the rule for adding radical expressions means if you have the same index, which we have here, and the same radicand, so here we have the same index right there, and we have the same exact radicand, same index, same radicand, we can add the numbers on the outside. So 3 plus 5 is equal to 8 square root of 55. So the answer would be 86 plus 8 square root of 55.